Okay, good morning, everyone, online and in person. Thank you for being here. Appreciate it a lot. So, I know we're so excited to be almost done this year. We have a total of three more tutorials because the week 12 tutorial would be a week after the week 12 lecture, which would be the 15th of April, and that's way too late in the school year. So, I mentioned it to Gavin, and he said that we don't have a tutorial for week 12. So it'll be today, next week, and then week 11, which is the final assignment I'll give out as well. So I know it's all crunched up a lot. So yeah, just a reminder, lab assignment 2 is done. So, I mean, if you haven't got that in, take your time to put it in, or whenever you can get it in, as soon as possible at least, ideally. And lab assignment 3, I know we just finished number 2, but just it's very awkward timing with the school year this time. The next one is in 2 weeks, so on week 11. And so I'm speculating what we could do for that. It's gonna be more fun, more enjoyable. I hope. I'm thinking of making like a rig for a unique object, like maybe a banana or something. Just having like it peel and then you just with the bones and everything, something like that. But yeah, that's gonna be in week 11. So just keeping that in mind, and it should be pretty fun. So, hey, today's agenda. What are we looking at today? We are looking at the reverse foot rig that we have discussed in Gavin's class. So I'm going to be going through what this is for, how it can benefit us, an example rig setup, and then a showcase. But before that, because we just finished our assignment twos for the most part, I just wanted to take a quick look at those and just see what we're working with, you know. All right. So I hope it was clear that we're expanding on the week 1 or assignment 1 with this file. I know this is very scary to look at, trust me, but let's see what we got here. Oh yeah, there's some twisting. So I recommended you to use the twist bones for the wrist twist, or the bendy bones for the wrist twist, because that's the easiest and most convenient way to integrate it. So you got some switching from Lucas. I think this is the stretching. Yeah, so we got the IK. And the stretching, the bendy bone stretching you can choose to do that. It usually will do that by default if you set it up the way I showed in the tutorial. If you need help with that, the tutorial from last week is there to refer to. But if you did everything the same way, you could do this in like an hour and a bit. This is Lucas, he did it literally in class within an hour and a half. I got some squash and stretch there. It's not the most perfect thing, but it does the job. And then yeah, all these collections. I made sure what I did was I separated out every single FK control, MCH control, and then the IKFK counterparts for those. Just because I like to have a very clean viewport, not just having everything all together like this. Right? Nice with some switching. Get some movement. Twisting. Excellent. I think, yeah. Okay, here's a good example. One thing about bendy bones is when you twist them, they can kind of curve really awkwardly at the wrist, and there's no real way to address that without knowing that there's one option you can click. Where is it? Is it? No. This is it. No, it's not. Oh, it is. So this is the setup from worked on last week. And if I take this bendy bone and I twist the wrist, you see how the twisty or the bendy bone just does not go flying or go like arching really weirdly. It's because in here there's a little option, ease in and out under the bone section. If you set out to -1 instead of 0, then you'll see it doesn't do that. Right? So this is annoying, and I'm sure there's other ways to fix it, but the way I found to fix it was to just turn the ease out to -1. And so that fixes that nicely. And if I, let's see. Yeah, and for this part of the bone, I just left it, it's kind of just constrained to this control 1-to-1. So this one does not arch or bend in the same way. But yeah, just thought I'd mention that. And it's literally just one bendy bone here doing its bendy bone thing. I give it 12 segments. And if you see here, there's these 4 extra bones. These are, I call them def B bones, so they're not actual deformation bones. You could call them like, they're technically mechanism bones, but I just call them def bones because it made sense to me. And so in this rig I gave you, you will notice there is not only the arm rig, but then there's the twist bones that are just a part of the rig already. And so those are just copying the transform of these, like 1-to-1 with these B bone def bones here. And then these ones here are constrained with an armature constraint. I'm pretty sure Gavin used this to show you the bendy bone. And so what this will do is constrain exactly to wherever it is on this chain, right? And so that's how you get these nice twisting. And because these bones are at the root level, these def bones, they will not be interfered with when I rotate the rest of the arm, right? So because of that, we can keep these twist bones within the def, or this is the intermediate bones, but we can keep them within the def bone hierarchy. And so when we export to the game engine, we don't have a really whack looking hierarchy of def bones under our armature. They're all just where they should be here, ideally, right? So we can leave all the weird hierarchy problems to our control bones and MCH bones, right? I think that's ideal. You want your entire deformation rig to be under one single root, right? Anywho. Oop, a little bit of problems there, yeah. Okay. Bit of, oh, I see. A bit of strangeness at the wrist here, or at the forearm. I don't think it's twisting fully here. Nice. Excellent. Yeah, that popping is annoying, but it's just inevitable. What I would do to fix the Euler snap is to just add a limit. To be like, yeah, it doesn't go there. And then your arm wouldn't twist that far if you're normal. So yeah. But these are looking great. Can't wait to go through them. So, yep. That's the Summit 2. Summit 2 would be even more fun. So, did any of you attend the tutorial or the lecture last week? Online. It was online, right? So in that lecture, we covered the reverse foot rig. And what is this for exactly? I'm going to answer that right now. That's for better foot movement. Reverse foot rigs provide animators with precise, intuitive control over where feet are placed during walking, running, and complex full body animations. They create realistic heel, ball, and toe rotations while keeping the foot firmly planted on the ground with inverse kinematics. Kind of think of it as the way to make a more complicated IK, not for the arm but for the leg, right? So it's a more advanced inverse kinematics. How can this benefit us? Saves us lots of pain. The realistic setup of this rig enables animators not to worry about fighting against the rig to get good animations. You can still animate with a very simple foot IK rig. However, this creates more challenge, especially with if you're doing like a walk cycle and you need to have, or you have your feet very precisely placed, makes it really painful to animate without this. So the animators can just focus on the animation and not worry about fighting against the controls to get what they want. And this also prevents unwanted floating of the feet, right? So if your feet are able to stay on the ground and then you can move your foot around it nice and smoothly, then that's great. So example rig setup. So I made a little attempt at creating my own version. I did not follow exactly what Gavin did. I just sort of took my own interpretation and researched a little bit on my own just to see my own perspective on it. And so I'm going to showcase that to you now. So let's dig in. So before I even go into that, I'm just going to open the project. So here it is. I just rigged the Beadrome model. And so first thing you'll see is just some yellow controls here. And I made sure to hide everything except what I wanted to animate with. So if I turn everything on here, that's the root. Got the def bones. And this is the rig that I worked on in class for the week 6, the body deform rig basics. And so in that we went through the process of adding the intermediary bones, which is not always mandatory, but it's good practice to know how to do it. And so we're never really using those def bones. They're kind of just always off, as I'll remind you. And they just have a copy location and rotation. You could also add a copy scale if you wanted, but copy scale always messes up with hierarchy-based bones, especially when you export them. So in this case, I just wanted to copy those. And so after we copy the location and rotation of every single def bone to its intermediate counterpart, we just hide them. So never to see them again, boom. And I prefer to use the B-bone visual for most bones. I just think it's nice and uniform, and you can easily change its size. So if I turn on the rest of the bones here, I think the MCH bones are where we really see something happening. So what's going on here? Everything that's green is your regular hierarchy-based mechanism bones. And then these orange bones here, I'm treating them as the IK control handles, pretty much. So in a regular IK rig, as showcased in the, let me just see if I can open another project. So as you can see here in the assignment, let me just hide some stuff. There. So our FK, this is the handle, and then all these MCH bones are IK to it, right? So this one's IK, and it's following this bone. See, LMCH IK wrist. And this is, wait, oh no, it's following the wrist here, right? But then this wrist is following the control here, right? But that's pretty much one step away, right? So what I'm doing is this bone here, the one that the IK is constraining to, are all these orange bones. So every single, so not of course this bone right here, but this leg has an IK constraint, so that enables it to move as a regular IK would, a regular IK rig would. And so what it's doing is it's constrained to this bone right here. So this is MCH IK ankle. So I can also pull vector. And so you see this next part of the foot here. This is there's another IK handle in here, and this one is pointing at or constraining to this bone right here. And so this bone is also constrained by these controls. It's sort of like controls are constraining these orange bones, and then these orange bones are constraining the rig itself, these green bones itself. And then these green bones are where the intermediate bones are being constrained to, right? And then finally at the foot, this bone is IK'd to this. This is the handle for that. And why do we do this? So I just mentioned that, all this. And so I made the control foot main pose as the main way to move the foot. And I also allowed you to rotate or to change its yaw, right? This is the setup that worked for me. And the reason I did this was because when you have all these bones here, you can order them in a certain hierarchy. And so the hierarchy I set was, this is the parent bone right here. And then this is the next in line, this is the next in line, this is the next in the hierarchy. And I'll show you that. So you see here, this is the foot roll, or the foot rig pose. That's what I called it. And then IK toe tip, and then IK toe, and then IK ankle. Right? So it's sort of, that's why we call it inverse foot rig, because it's starting from the, so this is kind of the overall transform, but then we're starting from the tip, and then we're moving up the foot itself, right? And so what does this enable for us? Well, first of all, I constrained this bone here, which is the parent of all these orange bones, to this control right here. So if I move it, it moves. Also, you can see here, it is copying the rotation. Oh, wait, not, sorry, yeah. It is copying the rotation of the foot main pose. And so if I move the position, it all moves together. And if I move the rotation, it's only x-axis. You can see that. Oh, sorry, no, it's only z right here. So I turned on only the z-axis. So when I turn it, it will only turn on that z. And I also made sure to lock the x and y rotation so that the actual control itself doesn't just move in a way that it shouldn't naturally, right? So that's also important to locking right here. So I can just place the foot wherever I want. but I can't rotate it any other direction. I can only pivot it like this, right? And so the actual reverse foot functionality, right, the real meat of why we're doing this, is done with two rotator controls near the heel of the foot. And so this allows for more complex movements with a simple rotation only. And this uses several green MCH bones with a one chain long IK constraint on each of them. And they are constrained to the orange bones, as I mentioned earlier. Right, so if I go here, you can see in the back of the heel, there are these two arrows that I noted here. And also note that they are not rotating, like their own local axis is not rotating with the rest of the rig, and that was intentional because I did not want them to kind of get confusing. I wanted them to stay flush with their axis, and so what I did was in the bone here, I made sure to turn off inherent rotation. So you can do that, and then if you turn that off, you see how if I turn it back on, it starts to mess with the foot, because the way I set it up, I don't want to rotate it when it doesn't need to, or when it's not being interacted with. And so if I rotate these, you'll see it moves the foot nicely. And I put a limit on the putting the foot back. You can see it ends there. I think forwards, it's pretty high. It goes pretty high. Look at that stance. And then the second one here is where you can get that on the toe pressure, right? And I don't think this is the most incredible way of setting this up. I was trying to figure it out as I was going along just to have an example, but you can see that this is demonstrating those different parts of the foot you can rotate separately, and that's because of the inverse foot reg functionality, right? Because this main one here is rotating the tip, and because that tip is moving the rest of the chain, because it's the parent, everything will follow suit. And so that's when we can get these secondary controls, which this mini one here is only constraining this bone here. So you see, boom, and then that one's for the smaller movement, right? And that just goes to show the power of that relationship. And the foot rolls with another control locked to a different direction. So I added a different constraint for that, or a different control for that. And as I mentioned, I locked all the rotation controls along a specific axis only, so that it prevents accidental rotations, as I showed you before. So you see here, this is the roll bone. This one only allows me to rotate it to roll the bone. I think it's a little off right now. Just reset all these. There we go. So I rotate this, you can see kind of rolls the ankle a bit. You can be more in depth with this kind of thing, where you can add a bone on each side of the foot, so that instead of it just rotating in some arbitrary middle point, it can rotate along those different pressure points of the foot. But here I just made a very simple roll along whatever axis. I think it messes up a bit if I rotate it this way. I think my rig is not fully polished up, but it does a job somewhat for forward movements. But yeah. There is also a separate toe control for finer placements. So this is just a regular, you can think of like an FK. Just kind of twist it backwards. Imagine you know, flex your foot back that far.
Okay.
You can?
You can?
No, I can't.
Well, you'd be so much better at climbing if you could.
Like if I like when I look at this, it just
The
looks like my
reverse
shoe.
toe hook.
The reverse toe hook, that'd be crazy. Yeah. No, this is like a regular toe. This is like a toe claw.
No, that looks like.
Like that's a real toe hook actually. Like that's a legit a hook.
That looks like some pretty regular toe flexion.
Does it?
Yeah.
Maybe I'm just not it. Where is it? There it is. Look at that. It's like a hook.
Mm-hmm.
That's crazy. But yeah, this is what I dream of as a climber. And also, I wanted to show there's there's a control to switch between the regular foot rig, reverse foot rig, and regular IK foot rig, using what we learned from the labs and the assignment. So if I, let's say I move this somewhere, there's this gear here. Whoa, it's another gear. Called it switch foot. If I, and what I did was I made sure to constrain it to this point right here. This is essentially the every part of the every control is constrained to this root part here. If I take this and I move it, it will nicely move, smoothly move to its regular foot rig counterpart. And the MCH bones, since I don't use these IK MCH bones, I just left them floating. So they're kind of doing their own thing. You can see. They're still pointing at these, right? So if I move them, see. But you can see here, this is just kind of like a regular foot rig. I can move it, rotate, and then toe. What would this be called? It's a climber.
I don't even know. I don't know. Like
Toe grip, toe gripper.
the gripper. Yeah, that would just be called using your gripper.
Yeah, yeah, putting grippers into it. Yeah, so simple. I just made those purple. And that's all for today. Thank you so much. I hope this at least provides you a bit of more insight on the inverse foot rig assignment. And if needed, definitely look online for some tutorials. There's always so many Blender tutorials on rigs online, on YouTube especially. So take a look there. This is just my demonstration of mostly that relationship of the inverse IK rigs like this, right? So those orange bones kind of in a reverse hierarchy up the foot from proximal to distal, right? And that's all. Thank you. And yeah, I'll give you this time to work if you want or do whatever. And yeah.